All right, lesson 10-1 for Algebra 1, exploring quadratic graphs. So we have looked at these graphs before in other assignments, mainly with your domain and range that I had you guys do earlier in the year. So we're dealing with the parabola. So this right here is your basic function, y equals x squared. This is what we call a parent function. Because that is your basic function. Okay? Parabola. Now, one thing that's really cool about a parabola, parabolas have what we call max and minimums, which are your vertex points. Now, one thing about this one, because that is the lowest point, this would be a minimum. Okay? It'd be a minimum. Now, what would happen? Oh, let me go over symmetry too. So I've got a line of symmetry that goes right down the middle. So if I were to fold this piece, it would map onto the other piece. And you're going to see later on what I'm talking about when it comes to the numbers as they're coming up when we're doing the table of values. You'll be able to see a pattern when it happens with parabolas for the whole symmetric aspect. So let's say I had y equals a negative x squared. What do you think it happens to a graph when it becomes negative? It flips it. Okay, it's just a reflection of it. So a negative is just going to take that parabola and turn it upside down. It's going to reflect it across that x-axis. Okay, it's going to reflect it across that x-axis. So it just takes it down it. So it's like a mirror image. Now this one here, again, highest or lowest point is your vertex. So here's my vertex. This would be a maximum because it's the top point. It's the peak. It's the peak of that parabola. So if I had coefficients in front of my x squared, so if it was bigger than 1, if my coefficient of a was bigger than 1, my parabola would be narrower. That means it would be narrower. It'd be a little bit skinnier. Okay? An example, let's say we had 3x squared. That is greater than 1, therefore this parabola is going to be narrower. If it's less than 1, not accounting 0, you can't have a 0 graph, a 0 parabola graph. If your a is less than 1, it is a wider graph. So let's say I had y equals 2/5 x squared. That's less than 1. Therefore, this is going to be a wider graph. Okay, it's going to be a little bit bigger. It's going to be out there just a little bit more. So that's what's going on with the difference between wider and narrower graphing. Okay, so let's look at some graphs. So on that very first one, table of values, which we've done multiple times with the table of values. So your table of values, I'm going to take -2, plug it in for x. Well, what's -2 squared? 2 negatives equal a positive. That's positive 4. 4 times 2 is 8. Plug -1 in there. -1 squared becomes a positive 1 times 2 is 2. Plug 0 in there, 0. What happens when you plug 1 in there? 1 squared times 2, 2. 2 squared, which is 4, times 2, 8. This is what I was talking about. Look at the numbers. They start coming down, but eventually they're going to come back up, repeating the same pattern for a lot of these. So again, let's go and graph it. -2, so always remember your x goes first, left to right. So we're going to go -2, up 8. 1, 2, 3, 4, 5, 6, 7, 8. -1, 2. -1 up 2, 0, 0. 1, 2, over 1 up 2. Look at that. Look at that symmetry right there. And then 2, 8. So this graph is going to look something like that. Okay? So the next one. Let's look at this one. Again, we're plugging in -2, -1, 0, 1, 2. Always use those. 0 is easy. I'm just going to mark it down as 0 because when you plug that in there, it's just going to be 0. So plug -2 in. -2 squared is 4. A negative half of 4 is -2. -1 squared is 1. A half of 1, or -1/2 of 1, is -1/2. Plug 1 in. What's 1 squared? 1. -1/2. Look at that. Look at the pattern again. And then 2 would be 4. So that would be a -2. And when you graph it, so we're going to go over -2, down 2. Over -1, a half. And notice I just put it right in between, make it a half. 0, 0. 1 -1/2. Again, look at that symmetry. And then 2 -2. So here comes this one. And one thing, what do I notice about it? So I look at those two. Because this number was bigger than 1, it's narrower. Well, look it, it's narrower. Because this number is less than 1, it is wider. So it widened up the graph. Because that's negative, it better be flipped down. It better be a reflection. So when you're graphing these, make sure that you are plotting them correctly. Because if they do not maintain a shape of a parabola, back to the drawing board. Okay, back to the drawing board when it comes to graphing these. Okay, a couple more examples here. Excuse me. So let's say I had y equals x squared plus 3. I'm going to show you a fast way to graph this one because there's no coefficient of x. It's a parent function. So I'm going to go a quick way of graphing these. Okay, a nice quick way. My y-intercept. If I plug 0 in for x, comes 0. Solve for y. My y-intercept is at 3. From there, because there's no coefficient, I'm just going to draw my parent function. Done. There's my parabola. Yeah, it's not precise, but a lot of times when you're looking at it and you're graphing these, especially at that college level, a lot of the times when you're graphing these, all you need to do is just find that translation. Okay? So I'm just going to find that translation, go up 3. Vertical translation, 3 units up, draw my little dot, draw my parabola. This one here, I can do a same concept, same quick concept. I'm going to come down here. My y-intercept is going to be a -6, so my vertical translation, I'm going to go down 6. Here, I'm going to think of that as slope. I know it's positive, so I'm going to go up 2 over 3. Up 2 over 3. I'm going to draw my parabola. And when you're doing it, especially at the college level, or if we're trying to eyeball it on those standardized tests, that's the fastest way to do those. So on some of those on the homework, the very last few, and I'll make a note in the Google Classroom, the very last few, I'm going to want you to draw them by hand like that. Because I want you to be able to recognize what I call a vertical translation. So I went down 6, put your dot, just like we did when we were graphing linear equations. Okay, y-intercept, y-intercept. We're going to do the same thing. Only this time when you're dealing with parabolas, translation, 6 units down. Vertical translation, 3 units up. And we're going to do it that quickly. So that I can show you guys how to recognize if you were given 4 different graphs in a multiple choice test, you'd be able to pinpoint the graphs, and they're pretty clear cut when you're trying to pinpoint those out. So there it is. Your basic introduction of parabolas. So there you have it.